Still talking about factoring today. Last time we learned two methods of factoring. One of them was the GCF, or the greatest common factor. And the other one was the factoring by grouping. So today we're going to see two more methods. One is called Trinomial Factoring. The other one is called Binomial Factoring. It's also called difference of two squares. Difference of two squares, we're going to see what that is in detail. So we're going to start with trinomial. Trinomial. Factoring. So last time again we saw GCF. Always look for a GCF or the greatest common factor first. If that doesn't work, then you try one of the other methods. You either try grouping, as we saw last time, grouping, or you try, if it's a trinomial, you try this method here that we're going to learn in a moment, called trinomial factoring. And or after that, if that doesn't work, if it's not a trinomial, if it's a binomial, you may try binomial factoring, which is also called the difference of two squares. So binomial. So this is your checklist. Every time you want to factor, always go by this order. So you first want to look for a GCF. That's the first thing you always do. If that doesn't work, then try one of these. Either this, and this, or this, based on how many terms and what type of terms we have in the trinomial. It doesn't necessarily have to be grouping. It could be either one of these three. We're going to see how that works in detail. So last time we discussed grouping and the GCF in detail. Today we're going to talk about trinomial and binomial factoring in detail as well. How many terms does a trinomial have?
Three.
Exactly, 3 terms. And a binomial has?
Two.
Two terms, that's right. So let's take an example for trinomial here. Let's say x to the second plus, let's say maybe 5x plus 6. As you can see, that's a trinomial. It has 3 terms. Okay. What is the coefficient of the first term?
What is the coefficient of the that's
not the power, the coefficient.
1.
1, that's right. There's always a number in front of the variable. If you don't see a number, that means it's a 1. What's the coefficient here?
5.
5, that's right, positive 5. And this is just a constant. These are terms with a variable terms. This is a constant. It doesn't have a variable, but you can think of it as x to the power 0. Okay, so this is what we call a quadratic term, or a polynomial with 3 terms of degree 2. This is basically in a standard form like this. You can call it a quadratic polynomial. Basically a quadratic trinomial, because the highest power is 2, so it's a polynomial of degree 2. It's also in this form of this quadratic expression. Actually, that's not what I meant to write. It's always in this standard form. There's a. There's always some a here to the in front of the x to the second. Then there is some b. Then there's some constant c at the end. For example, for this one, what's a, b, and c? For this trinomial here again, what is a, or the coefficient of x to the second? That's
1.
And b is
5.
1. Wait.
It's 5. B is always next to the x. You could be positive, so you take it with the sign, so it's positive 5. And of course, the constant c is
6.
6. Okay, so all the polynomials, all the trinomials, the type of trinomials we're going to be doing today are mainly with the second degree. So second degree, 3 terms like this. We're probably going to see some third degree as well, but it's done the same way. So when you see a trinomial, think about this form, standard form of a trinomial with degree 2, standard. And so to factor this, so believe it or not, first we're gonna factor this even though we don't see a GCF. There is nothing common between these 3. So always look for a GCF first. If that doesn't work, then you try one of these 3. Obviously, we're going to try trinomial factoring because this is a trinomial with 3 terms. If this was a binomial with 2 terms, we would try binomial factoring, either with the GCF or with what we call the difference of 2 squares, which we're going to explain later. And grouping, as we saw last time, involves like 2 groups of usually the same number of terms, either groups of 2, groups of 3. So we group each, we factor each group first, and then after that we see something common between the resulting terms. So now there's no GCF, nothing is common. X is not common because it's not here, so it's not a common factor. We can't use grouping. Grouping usually it requires 2 groups, for example, 2 terms and other 2 terms, or maybe 3 terms and 3 terms. So that doesn't work, this doesn't work, so what's left to do is to try to factor using what we call trinomial factoring. So this is how it's done. So after you exhaust all the other options, GCF and the other ones don't work. So first you check. So again, we said that the coefficient here is 1. So if A is 1 and the degree is 2, that's the degree of this polynomial. Let's call it D, is 2. If and only if these 2 are met, then you could go ahead and immediately draw 2 sets of parentheses, start each one with X. Then we only need to figure out a couple of numbers here, and the factoring is done. You remember last time factoring was turning additions, for example, A, B, C, into some product, C times D, times D. So we have addition here, additions. So we're going to turn that into some C times D. The only thing left to do here is find 2 numbers, not random numbers. We're going to find those numbers based on these coefficients, based on A, B, and C. Again, first check if A is 1 and these 2. Only if those 2 are met, you can immediately write these parentheses and start each one with X. Why do we start each one with X? Because we have X2. If we times those 2 to distribute, you're going to get that second power. Now, how do we get these 2 numbers? Does anybody know how to get these numbers here before I explain it?
How to get
Does anybody have any
which
idea?
numbers?
Say that again?
Which numbers? I'm sorry.
So we need a couple of numbers to put here, and then the factoring is done. So how do you find those numbers based on 1, 5, and 6? So if someone has an idea on it, if not.
Do you start with order of operation?
What do you mean by that specifically?
Like the 1x to the second power, and then like go from left to right, basically.
So here we're not trying to simplify it to use the order of operations. We're actually trying to put these together into a multiplication. So here's the deal here. So again, make sure these 2 are met. Make sure the coefficient A is 1 and the degree is 2. If you have 3 here and 5 here, it will be a different procedure. We're going to do that probably another time. So here's how you find those 2 numbers. Those 2 numbers must multiply to this number here. That's by itself, which we called C. This is C. And the same numbers that you multiplied here to get this number, when you add them or subtract them, you should get this number here, b. Okay, so two numbers are multiplied to c and add up to b. So let's write that down here. So we're going to find a number here times another number. We should get exactly c. Okay, the number c here is positive 6. And whatever number you used here for multiplication, use them again, either with addition or subtraction, depending on their sign. On their signs, that's what decides whether we add or subtract the values. And these two numbers must add up or subtract to exactly b. b here again is the coefficient of x. So it happens to be positive 5 now. Could be a negative, so be careful when it's a negative. So this is basically c. This is b of the standard form, so a, b, and c. So what numbers multiply to 6 and add up to 5? There's only one combination that should work for both. You may get
3, right?
again
2 and 3.
2 and 3, both positive, right? So 2 times 3, you get positive 6. If you take the same numbers here, which are positive 2 and positive 3, take the same numbers and positive 3. Okay, so this time we're adding them because they both have the same sign. So if you add the two numbers, you get exactly positive 5. So those are the numbers that we need here. So they multiply to c and add up to 5. The numbers are positive 2 and positive 3. And that's it. So we just factored this. We turned additions into a product. That's the purpose of factoring. How do you check to go back to the original expression? What's that process again, to go back from here to here?
You just multiply.
That's right. When we multiply or distribute, we can get back to the original expression. In case you don't believe it now, you can easily prove it yourself. Just by distributing, you will get exactly this. But assuming you get the right numbers and the right signs. So that's how easy it is to factor a trinomial when you don't have a GCF. When you can't use grouping. This can be done in seconds. You don't have to write all these explanations and steps. All you have to do is write this step and this step right away. We'll see later with experience you can do this in 3 seconds. Once you figure out the numbers, you're done. Okay. So again, you don't have to do this on the side unless you want to. If you want to spend a lot of time finding the numbers. But usually that's something you can find immediately. It gets a little tricky when you have negatives here, 1 or 2, but we're going to go over each case of those. Okay, so let's take another example. Okay, maybe x to the second plus 7x plus 12. Again, we have this trinomial. We want to factor it. Always look for a GCF. Do we have a GCF or a common factor here for these 3 terms? Do you see a common factor there?
X.
Is x common? Do you see it in all of them?
Oh, no, you're right. Sorry, you're right.
X is not common. No number is common. Nothing goes into 12 and 7 and 1 at the same time. Unlike, for example, if you had 3 here and 6 and 12, then 3 would be a common factor as we saw last time. So there is no GCF. So always look for a GCF first when you factor. If it doesn't work, that's when you try one of these 3. Since it's a trinomial, so let's try trinomial factoring. What's the first thing you check in a trinomial before doing the parentheses again? You need to check if a is 1. Is a 1 here?
No.
A, is it 1?
Oh,
1.
it's
Yes, 1.
That's right. A is 1. It's invisible again. Invisible.
yeah.
And the degree is
2.
2. If you have these two, if these two conditions are met, and then you can write your parentheses right away, start them with X. If you see a different number here, for example, 7, and you see here 5, this is not going to work right away. You have to try to factor a different way. But with trinomials of degree 2, we check for these two first, and if that's met, then
Professor, what do you mean
right.
if the power is gonna be, you just said like 5 or 7, so we're not
Yeah.
gonna do it that way?
So this way here works, this specific way works only if you have A here, 1 and 2 here, 1 and 2. Trinomial with degree 2. There's no higher power than that. If it's 5 here or 6, there are other methods of factoring, if it's factorable, okay?
Can you show it, please, after that?
That's not for now, but after we go,
Oh, okay. So we
we'll
don't-
probably do power 3 or 4
Mhm.
after we cover this. So again, this check if this is 1 and 2, you have trinomial, no GCF, then you can immediately write these. Now we need two numbers to fill in these gaps here. How do you find those numbers again? Just like we did earlier. What numbers?
X plus 2.
How do you find them? How do you find the numbers?
Instead of X, we're gonna put 1.
So we need two numbers that multiply to what?
The greater common factor, you said?
So we need two numbers that multiply to what? Just like we did here. Two numbers should multiply to C. What's C here?
12.
12.
12. Same numbers. Add or subtract to what number? Just like this problem. The same number.
5.
You should, no, for this trinomial, the same number should
No.
multiply.
Oh, 7. 7. No.
Right.
7.
7. Positive 7. Okay, so you find two numbers that multiply to this number. Same numbers used here. When you add them, you should get this number here, positive 7. Exactly like we did here. So two numbers that multiply to 6 and add up to 5. So what numbers multiply to 12 and add up to 7?
5. I think it's 4.
What do you
4
mean?
and 3.
Which numbers multiply to 12 and the same numbers add up to
4 and 3.
4 and 3. So you can get 12 in different ways. 12, we can get it by multiplying 3 and 4.
Mhm.
You can also get it by multiplying 6 and 2. And you may get it by multiplying 12 and 1. So we can get this one in 3 different ways, but only one of them can give us this and this. So can you get 7, for example, can you get 7 from adding or subtracting these two?
No.
No.
That's not gonna work. Can you get 7 by,
No.
it's not gonna
No.
work. So that's the only one left. So only
So we just add 3 and 4 and we get 7.
So if you want 12, so this has to be positive. And then you check if these two add up to the same signs here. We have positive 4 and positive 3. See if they add up to 7. In this case, they do. So in this case, we're adding because they're both positive. So it's 4 here and 3. And we're adding them because they're both positive. As you can see, you will get exactly this and this. So the numbers are positive 4 and positive 3. Positive 4 and positive 3. And again, you can easily check by distributing and you will get back to this expression. It's a pretty simple way of factoring. You just need to find the numbers. So 2 steps, check, make sure you have 1 and 2 here. And it's a trinomial, of course. Then find 2 numbers that multiply to C, this number, and add up to this. Always start with the multiplication because it narrows down the choices of finding B. 7 you can get in many ways. You can get 7, 1 plus 6, 2 plus 5. You can get it in different ways, but this is usually limited. So start with the multiplication, and this narrows it down to one option to find this number B. Okay, so with addition, no problem. So two numbers are multiplied to this and add up to this. When you have a minus in there, that's when it gets a little tricky. So you need to involve your, let's say, if we have this, maybe start with a plus first. Okay, once you add a minus in the trinomial, it gets a little harder to find the numbers. But again, you need to know your signs very, very well. You need to know the signs of addition, subtraction, the multiplication, also division. You need to know these very well for different operations. So now, can we use trinomial factoring? First of all, again, do we have a GCF? Do we have a common factor here?
No.
No.
There is no common factor. So which one of these methods are we going to try? Is it grouping, trinomial, or binomial?
Ruben?
There is no groups, I believe.
But do you see two groups here right away? Do we have
No.
No, it's only it's an odd number of terms. But if
Oh,
you
the
had four
trinomial.
yeah, if you had 4 or 6 or 7, then you may try to group. It looks like a trinomial, so why not try trinomial? Okay, it's a trinomial, so try it right away. Before you try trinomial, you check for a couple of things here. What do you check for?
Coefficient and power.
Well, one. Okay.
Based on this, can we use trinomial factoring?
Yes.
Yeah, so we have 1 and 2. So you're right, your parentheses. Start each one with x. Then we need a couple of numbers to put here. How do you get those numbers? They must multiply to what? The numbers must multiply.
Get 6. So 3 and 2.
So they must multiply to -6, not just 6.
Negative.
What is the coefficient of this term?
1.
1. So we have an invisible 1 here. So the numbers should multiply to c, which is -6. Same numbers that you used here, when you add them, when you combine them, you must get +1. So when you add or subtract, you have to get exactly +1. Now, let's find the numbers. What numbers do that?
-6, right? Not just 6. So,
yeah, so we need two numbers. Mm-hmm.
So it couldn't be 3 and 2, like -3 and 2?
Possibly. So let's try. You want to try?
But
You want to try 3 and 2? If you try 3 and 2, this has to be negative. That means one of them has to be negative. Which one do we give the negative to?
-2. Because
3. 3 is.
It will depend on this. So we want so the multiplication is negative. That means one of them is negative. We don't know which ones will depend on B. We want their sum or addition to be a positive. So which one of these gets the positive sign?
-2.
2.
Which one gets the positive sign out of these
3.
3. So the combination of the two is positive. That means the higher of the two should have the same sign as this number. So let's try that. So we said 3 times -2 is in fact -6. That's good. But let's see if that works to get +1. If you use the same numbers here, we have 3 and -2. So we can use a negative here. Do we get +1?
Yes.
Yes, we get exactly what we want. If you switch them, it will not work. If you put a minus here and a plus, you will get a negative here still. But if you put a minus here and a plus, this will end up as a negative.
-1, yeah.
So play around with the signs. Make sure you get exactly this when you multiply and exactly this when you add or subtract. So again, there's no room for mistaking the rules of the signs. You have to know those very well in order to get this done correctly. So check again. 3 times -2 is -6. 3, same signs here. Don't switch the signs. Use the same ones used for multiplication. Just write the numbers again. +3 here, -2 here, you get exactly this. So that works for both. There's always one combination that works for both. You can't find two. So the numbers that we look for are positive 3. So we're going to fill that out in the parentheses. And the other number is negative 2. Again, you don't even have to write this step. You can just write this in one step. And again, you can easily check by distributing. So this factors into this right away. Okay, does that make sense, everybody? You got that problem?
Yes.
Everybody in the room, does that make sense?
Yes.
Yes, it does.
Yes.
Might still seem a little ambiguous at this point, but trust me, it's gonna make more sense as we go. We're gonna do plenty of examples. So let's switch things up a little bit. Let's do the same one here. Or maybe take another one close to this, but change the size a little bit. Let's say, let's make this a positive 7x. But actually the opposite. Let's make a negative 7x, positive 12. Again, whenever you see a minus in 1 or 2, you gotta be more careful with the signs. As always, can we use GCF? Do we have GCF?
Trinomial.
Do we have a common factor here?
No.
No. So if you don't have a common factor, that's when you try one of these. Obviously, it has 3 terms. We're going to try trinomial. Can we write the parentheses right away like this and put x and x?
Yes.
Yes. Why? Based on what? Exactly here. Based on 1 and 2. You can only write this if you have 1 here, invisible 1 and 2. You can immediately write this. Always check for a has to be 1 and the degree is 2. It's trinomial. And you write your parentheses. So we need 2 numbers now. What numbers do we need to complete the parentheses and the factoring?
To get 12.
That's right, we need to get
And
positive
minus
12.
7.
So 2 numbers that multiply to positive 12. It's a positive here. And the same numbers that we use for multiplication, they should add up or subtract to what number?
Minus 7.
That's right. This number here, it's a negative, so they have to add or subtract to it. What numbers, again, multiply to 12 and add up to 7? This might help. You just need to use the right signs. So what signs do we use to get exactly positive 12 and negative 7?
Positive? But negative 4.
Negative 4.
Negative 4.
So 2 negatives, no?
2 negatives, okay, like this.
3.
Yeah.
So since this one is positive, you get a positive.
Positive.
That's right. You get a positive either by multiplying 2 negatives or 2 positives. So whenever you see a positive here, you could still use 2 negatives or 2 positives. So negative 4 times negative 3 is positive 12. Keep the same numbers here. If we combine these two, do we get negative 7?
Yes.
Yes, exactly. So negative 4 minus 3 is in fact negative.
Because you add and
negative
you say
7.
Negative 4 plus negative 3.
That's right. When the sign is the same.
You keep the signs and you add it.
Exactly. For subtraction, we keep the sign and we add them. But for multiplication, the 2 negatives turn into a positive. So the numbers that we're looking for here are negative 3, negative 4, and negative 3. And that's it. The factoring is done. Again, you can always check by distributing, and you use the FOIL method that we learned with multiplying polynomials. If you distribute this, you'll definitely get back to this. So that's how factoring of trinomial works when it's in standard form like this. And you have 1 as a fact as a coefficient here, you have 2 as a degree. And the more signs you see, the more negatives you see, the more careful you need to be to get the right numbers. Okay, everybody, still on board?
Yes, okay.
Yes.
All right, so please feel free to ask, to intervene, engage if you have any questions. Let's do one more. So it's pretty much the same concept every time. Just play around with your signs. So remember the two main steps, 2 or 3 main steps. Check for a GCF first, then check for A and D. Then find the number. So it's 3 steps. Let's make up another problem. This time I want to make this so minus x. The second, and I also want to use maybe -2 here. Okay, I want to use these 2 numbers, but before that, I want to make this maybe 3 here. I want to make this 6, 6, and 12. Okay, so again, the purpose is to factor, turn this product or turn this addition, something like this, and into a product. What do you try first? Well, what would give me the first step? So I already gave you the 3 steps. So tell me, which one do you try now?
Which number goes to 12 when
Before that.
multiplied?
No,
Wait, before that.
A1, right?
Even before that.
A1,
Before
6,
that. Before we use trinomial factoring.
A, B, and C?
Before that, before even trying trinomials, what do you try first?
graphing.
So look at this diagram here. What do you try before?
What is the common between?
That's right. Always look for a common factor first. Let me write this again
Like
here.
grouping.
So
Well,
first,
I said it, Professor. I said it, which number goes in both?
no, before that, before we use trinomial, see if we can use GCF. And if we use GCF here, do we have a GCF? They check for GCF. Then if the GCF doesn't work, that's when you try, in this case we have 3, so we're gonna try trinomial. And when you try trinomial, that's when you check for A and D. So don't jump right away to use trinomial. We use that as a second way after GCF doesn't work. Do you have a GCF here or a common factor?
Yes.
We have the same coefficient.
Which
so
is?
6 and 6.
That's right.
So
2 is a common factor, 3 is a common factor, 12 is 6 is a common factor. Which one do you usually use? Or which one do we
The
have?
highest one, which is 6.
Exactly. Yeah, that's why it's called the greatest common factor. The greatest common factor. So before you attempt trinomial, get rid of the GCF first. 6 is common here. Open the parentheses. What do you do with these 3 now and 6?
Don't you just divide it?
That's right. We're going to divide all these 3 by the GCF. What's 6x to the second divided by 6?
I'm sorry,
X
what?
to the second power.
X to the second, 6 cancels. If you divide these 2,
Just minus 6.
X. Oh,
Right.
minus X.
Minus x, yeah.
Finally, 12, take away 6.
So
That would be-
Minus 2.
So first, we had to use GCF. After the GCF, see if you can use another method. Can we use another method of factoring here? Especially if you look inside the parentheses. What is this again, inside the parentheses?
So now we can use trinomial.
That's right, it's a trinomial. It has 3 terms. So now we can use it. See if we can use it. It's not always possible to factor with a trinomial, but we're gonna see if we can factor. So this is gonna be 6. And before you use trinomial, what do you exactly check for again in the trinomial before you can use the
Coefficients, it's going to be 1, 1, and 2.
One and two, yeah.
Exactly, 1 and 2. So the third step here, make sure A is 1. Make sure D is 2. If you have that, then you can immediately write 2 sets of parentheses, start each one with X. Don't forget about this GCF. It's a part of the expression, so don't ignore it. You gotta bring it down. What's next?
So we have to find -2.
That's right, 2 numbers that multiply to -2. Same number,
And-
add up to what?
And -1.
Exactly.
-1.
2 numbers that multiply to C, which happens to be -2. Same numbers, either add up or subtract to the coefficient of X here, which is a -1. So that's important. That's a -1. All right, so do a lot of math and tell me which numbers do we use here.
-2 and 1.
Let's try that. So you say -2 times 1.
One, yeah.
Let's see if it works for multiplication. -2 times 1. Yes, in fact, it's
-2.
But does that work for this? If we use -2 and +1, so +1. So we use -2 here, +1. Is -2 plus 1 -1?
Yes.
Yes, so that works for both. So if you don't get exactly this, you may have to try the signs again, and you have to try other signs. So the numbers are exactly -2 and -2 and +1. And that's it for this one. So it took 2 steps. We had to do the GCF first. After the GCF, we had to do trinomial. Okay, so keep that in mind. Always try the GCF first. If that doesn't work, we have other methods that you might try to factor. And as always, not everything can be factored. So sometimes you may run into something like this. As we saw last time, we said, how do you factor 15 again? How do you turn 15 into a product? Into a multiplication?
3 multiplied by 5.
3 times 5. These are the factors of 15. What about 17? Can we write it as a multiplication in numbers other than 17 times 1? Can we find 2 numbers that multiply 17? Whole numbers?
No.
No. So, because 17 is, we can't break it down. What kind of number is it?
It's gonna be like with a half, 8.5.
Without decimals. We're looking for whole numbers only,
Oh.
right? Integers. What kind of number is 17, since we can't break it down?
That's a prime number.
Exactly. Very good. That's a prime number. And if a number is not prime, if it's 15, what is the opposite of a prime number? Starts with a C, if that might help.
I don't know.
Finish.
Common number?
No,
Composite.
composite.
What is it?
Composite. So basically it's composed of these two. So this is a composite number, this is a prime number. 17 can only be 17 times 1 when we talk about integers. Same thing with all these polynomials. Sometimes we can factor them. All these problems we've done so far are composite. Sometimes you can't factor them. No matter how you try, it's still difficult. You can't find the 2 numbers. Here's an example here. So let's say x plus 7x, maybe plus, I don't know, 11. First of all, yeah, we can go ahead and attempt the parentheses. Because we have 1 and 2, you can try that. Now we need 2 numbers that multiply to 11 and 2 numbers that multiply to +7. 2 integers, that is. Can you find 2 numbers that multiply to this and add up to 7? Can you find that? Start with the multiplications. What numbers multiply to 11?
11 to 1 is just a prime number.
Should be exactly 11 to 1. It's in the composite number. There's no other way. Can you get 7 from
Same.
adding or subtracting these?
No.
No. So this is basically a prime. This is a prime polynomial, just like a prime number here. You can't factor that. So this is what we call prime polynomial or trinomial. So keep that in mind. Sometimes it's not possible to factor. We could involve decimals or radicals, but we don't want to deal with that at this moment. So we only want to deal with integers. Okay, so after you exhaust all the options, you try all the combinations and signs, then you may say it's trinomial. But most of the time, there is a solution. There is a way out. You just need to work with your signs and see what works and what doesn't. But again, it's all about the signs. So you have to master, I say master the signs of addition, subtraction, multiplication, and division. If you have a problem with that, make sure you review that and get comfortable, get familiar with these signs. So that's basically how you factor trinomials. We probably, okay, let's do another one, another trinomial, maybe with a different power. Let's say x to the second, something like this, x and x, also x here. And let's use maybe 20. Okay, and some powers here. Again, we have a trinomial here, x3, x2, x1. We want to factor it, so we're going to attempt, as always, the GCF. This one is a bit different because the power is higher, it's 3. Do we have a GCF in these 3?
No.
We have to group them.
Again, look again. Do we have a common thing between those 3 terms?
Actually, x. No.
X. That's right.
Okay, but there's different powers, so it doesn't matter.
Which one do you take as a common factor when you have different powers?
The lowest one.
The lowest, as we saw last time. We use the lowest power. Okay, because x is common, so we're going to write x, the GCF. There's no common number here. If you have, for example, another number here that's common, you can add that to the GCF. If not, for this time, only this one is common, so the lowest one. And again, what do you do with these terms and the GCF? What do you do to factor? What's the operation?
Divide.
That's right, division. So x3 divided by x1 is?
x2,
x2 plus, divide this by x1 would be 9x.
Oh, 9x. Yeah.
9x1, if you subtract the powers, finally, 20x divided by x will be?
20.
Oh, is there a 20x?
It's just
going to be 20.
Just
20.
20.
Right? x1 and x1 cancel out, just got 20. That's the first step, GCF. What else? What do we do next? What do we do next? We can attempt to factor this trinomial inside. Can we use trinomial factoring here? Can we use trinomial factoring
Yes.
here? Yes, because we have 1 and 2. So bring
So
this down to CF.
A1.
So we're going to do x. Because we have 1 here and 2, we can start 2 parentheses.
Yeah, so
And
what?
we need 2 numbers that multiply to what?
It's
11 and no.
2 multiply to 20 and add up to 9. Always start with this one. This narrows down the options of this.
it's a 5 by 4.
So we have 5
Oh,
times
5
4.
by
What
4.
other numbers multiply to 20?
20 by 1.
20 by 1 and 10 by?
10 by 2.
That's right. By 2. So which one of these will give you 9 if you add them or subtract?
5, 4.
Not this one, not this one. So we're going to use that. Everything is positive, so no problem. Just use the positive sign. So if both are positive, it's going to be positive here. If one of them is negative, that's when you play around with the signs a little bit. And this is your final.
Wait, I'm sorry, I'm kind of got confused. Why
Mhm.
did we pick the 5 times 4?
Because 5 times 4, so we must
20.
multiply to this and add up to this one.
What do you mean by add up to?
Add up when we add them or subtract.
Oh,
Okay?
okay. Oh yeah, I got
Like
it.
to get 20, you multiply 5 by 4, and
I
to
know.
get 9, we just add them.
That's right.
Okay, I got it.
If you try to get 9 from these, it won't be possible. You can't
Yeah.
get 9 from 10 and 2 or 12. So this is what we call factor completely. So the question may say factor completely. That's a hint that you may need to factor more than once. Okay, so don't just stop after one thing. You may have to factor twice or more. So GCF, then trinomial, or if it's a binomial, termed binomial, so completely. Okay, the question says factor completely, then that means factor and factor again if possible. So that's all for binomial, for trinomial. Binomial involves 2 terms. So pretty much everything of the same main steps, but factoring binomials is a little different. So let's look at that now. So trinomial, number 2 would be binomial. So binomial factoring. Simple example of binomial factoring would be something like this. That's a binomial. As always, we look for, what do we look for first?
The common thing is going to be 6.
Did you see it?
So-
So the highest one here is 6. We have 2 and 3,
6.
but 6 is higher, so we're going to put 6.
6
On the
x
parentheses.
x in square
That's right, divided by 6, we get x
Yeah.
squared.
plus 2.
Divided by 6 is 2. That's it, we factored it.
Yeah.
But sometimes we run into some special cases, like this one here. That's a binomial, has 2 terms. As always, look for a GCF. There is none here. We don't see any common thing. Obviously, we can't use trinomial because it's a binomial. We can't use grouping. So does anybody know how to turn this into a multiplication? How to turn this into this subtraction into a multiplication?
Can you use A and B here?
Okay.
So is A gonna be 1? No.
Okay, A is 1 here.
Yeah.
B is, this is C actually. We don't have B. So B
Okay,
is
yes, yeah.
B is 0. Technically, we don't have the middle term. So that means B is 0. So this is not existent because B is 0. But
Okay.
so we have only 2 terms. So we can't use the same method as we did before with this one.
Okay.
There's a special formula that we used before with multiplying polynomials. We actually went backwards. When multiplying polynomials, we did this. We went from here to here. Today, we're going to go backwards. I believe I mentioned it earlier. So let me show you how that works.
It isn't going to be x minus 3, x plus 3.
Okay, that's a good guess. That's nice. Let's see if that's in fact the actual factoring. How do you check if this again is the right factoring of this? How do you check?
Multiply x by x, x to the second
Exactly.
power.
So let's distribute all this and see if we can get this.
Minus 3.
So this is going to prove this backwards. So assume this is correct. Let's prove that it's equal to this. So let's write it over here. The FOIL or the distributive property we saw before when we dealt with polynomials, x times x, that's x to the second, x times positive 3, positive 3x. Negative 3 times x is negative 3x. Finally, negative 3 times positive 3 is negative 9. What happens to this now? Can we simplify it?
Yes.
How?
So
That's
plus 3x minus 3x, it's gonna disappear.
That's right. These two cancel out because they're opposites. We have negative and positive. What's left is just x to the second and
Minus.
negative 9. So this is actually true because you see, we multiplied it and we got back to this, as you can see. So let's try to conclude or try to make up a rule that we can use every time without having to do this. So we're going to try to skip all these steps, 2 or 3 steps, 3 of them. We're going to try to skip this, instead do this in one step. What do you notice here? So we have x to the second here. So we took x. And also here, 9 is basically 3 to the second. 9. Let me write it separately here. 9 is basically 3 to the second. So what do you notice here? We just take the bases of the second power. So if you ignore the 9 here, let's just ignore the 9 for a moment and then write it as 3 to the second. So to factor this, you can do it quickly in one step. Basically, just take the bases here, take this without the powers, write it once, and then repeat the same thing with a plus. Of course, a multiplication in between. So just take that, flip the sign. Okay, so whenever you have something like this, that's what we call the difference of 2 squares. Difference means minus, and we have 2 squares, 1 on each side of the minus. Okay, that's the difference of 2 squares that I talked about earlier. Okay, the sum. Let's focus on the difference of 2 squares for now. The sum can't be factored, and we're gonna see why. So binomials including the difference of squares. So whenever you have difference of squares, that means you have a minus and 2 squares on each side. Write the bases in parentheses, and then repeat the same thing with a plus. Does that make sense to everyone? This is an easy trick, an easy shortcut. We can factor without having to actually do all this. So this is one of those special factoring techniques. Let me give you another one here. Let's actually write the rule. In general, if you have a minus b to the second, these are just some random numbers. How do you factor this again immediately in one step based on this?
A minus b multiply
Multiply what?
a plus b.
A plus B,
Yeah.
that's right. So just take that.
Isn't that an algebraic formula?
That it is. This is a special formula, like I said here. So this is one of these useful formulas. So whenever you see difference of 2 squares, you can rewrite this right away like this. Or if you have to, you can go backwards. If I give you this to multiply, you don't have to distribute and do all this. You can immediately turn it into that. So that's another special way of factoring. So this was a special formula here when we use ABC. That's also another one when we have two. We have 2 of those. Here's another one. Let's try to do this quickly here. Let's say if you have x to the second minus 25. How do you factor this into, what is the factor?
X
minus-
negative 5.
Yeah, x minus 5, x plus 5.
That's
Yeah.
right. So we have x to the second.
Because square root of 25 is 5, so basically 5 in square.
Exactly. So to use the rule, we need what we call difference of 2 squares. You have to have 2 squares. Here, one of them is visible. The other square is not visible. So you can make it visible first. You can say 5 to the second. Once you have 2 squares and a minus in between, so we're going to take the bases, just like they appear without the power or the powers, and repeat the same thing here with a plus. And the factoring is done. And you could even skip this step. You can skip this right away just do this, and you can move directly to this step. So that's one of those special formulas that save time. We can use them to factor right away. There's another case. Let's say, what if you have x4 minus, let's say, 81. As always, attempt GCF. Do we have a GCF?
That's going to be x4
Before
minus
that, before we get-
9, 2.
Before that, give me 1 second. Before we get
Okay.
to the answer, do we have a GCF first?
Uh,
We don't have a GCF.
Yeah,
No, we don't
no,
have.
we do not.
Then which method again do we need to use from here?
Binomial.
Binomial.
Binomial. Obviously, we have two terms,
Yeah.
not this, not group.
Yeah.
And when you say binomial, we mean the difference of two squares. Difference of two squares. That means we have to have a minus in between, some square here, and some other square on the other side. If you have this, you can immediately write x minus y times x plus y. Or if you don't have two visible squares, see if you can make two squares. Obviously here we don't have two squares, but let's see if we can make two squares out of this. At least for 81, it's easy, right? We can write 81 as what?
9 square.
Exactly, 9 to the second. What about this? We need it to be squared, so we need the outer power to be 2.
It's
So
going to x in square.
that's right, so this has to be x squared as well. Because we want the outside to be 2. So we move that out. We want 2 here to be outside because the formula requires 2 squares. Now, since these two multiply, if you remember this rule from multiplying or from the rules of exponents, what do we do with a and b?
A plus b.
Not plus b, but
Oh, the
Multiply.
like
that's right, we multiply them. So a, b. So again, we needed that 2 to be outside. So put 2 outside, and then see what's left here. What number multiplies by this to get this? So obviously, we need a power here to multiply by 2. First, you put the 2 here because we need it for the formula. Then you figure out the number here. So x or 2 times 2.
Where did we get 9 from?
From 81. 81 is 9 to the second.
Mm-hmm.
Okay, so this is 1 here. So you make 2 squares. If you don't have 2 visible squares, you need to make 2 of them visible. Once you have 2 squares, then now what is the factored form as we saw here? So once we have 2 squares, just take what's under the powers. Take under what's under these squares. So what goes now here? What's the factored form?
X
Oh.
to the second
x to the
power.
second minus 9
That's
to
right.
the
Just
second.
exactly. Just ignore the outer powers, ignore the 2 powers here, and take whatever is under them. So if we ignore this 2 and this 2, so we're going to take this. So x
X to
minus
the
2
power.
minus 9. And
X in square plus 9.
that's right, x plus 2 squared. Okay, and that's good. Do you think we can factor this further?
I believe we can.
Can we use a difference of 2 squares again here? That's
Yes,
basically
it's
this. That's what we had earlier. This was x to the second minus 9. We turned it into this, then into this. So now, so this is x minus 9, x minus 3, x plus 3. This one is just basically this. Okay, so this turns into those. What about this? What do you do with that? Can you factor it?
yeah, wait. Yes, I believe.
How? How do you think we can factor this? Is it the difference of 2 squares? Do we have difference? Difference again means a minus in between. This is the formula for difference of two squares. It has to be a minus, not a plus. So you might be thinking that,
Isn't it x2 plus 2ab plus b in square?
that's if you have three terms. So you don't have that 2ab in the middle. We don't have it here. So this is the sum of two squares. This is the difference of two squares. We can do this, but with the sum, as I said earlier here, the sum cannot be factored. So the sum of two squares
Cannot be factored.
do not make the mistake. I'm sure you might be thinking about x plus 3, x plus 3.
It's not
Will
gonna
not work.
be that.
This will not work. So if you think it's this, you can try to distribute and you will not get this. So only works if you have difference. So this is basically another prime. So x to the second plus 9 is prime, cannot be factored. So this stays the same here. Okay, so unless you have, let's say, maybe 3 here, then you can at least use GCF. You can factor 3 out. So always attempt GCF first. If it doesn't work, then you try something else. But in this case, this cannot be factored. It's prime. So that's basically how the difference of two squares work. If you have two squares, two visible ones, again, always try the GCF first. If you have something like this, you can factor it. Notice that we can't factor this because this is the sum of, actually it's not even the sum of two squares. This is not a square. Unless you use the square root of here, square root of 2 to the second, but it's another problem. Try GCF first. If it doesn't work, then if you have a minus and you see two squares, or you see that you can make two squares out of it, then you attempt to do that. Let's do one final example here, another case. Let's say, everybody here, before we go to the next problem, any questions at this point? I'm addressing everybody in the room, all 20 or 17 of you. Any
No,
questions?
not for me.
Okay, everybody else, you guys?
No
okay?
no questions for now.
Are you getting all of this?
Yeah, everything but the last one.
The last one was a little tricky, yeah.
Yeah.
I'm gonna do another one quite similar to it. Everyone else, again, you guys getting all this? Please let me know if you don't understand something so we could go over it again. So check this out, this other problem. And minus maybe 25.
Is that a 9x? Oh, okay.
That's right. So again, the checklist always try GCF. In this case, we're going to try GCF and see if it works. If it doesn't work, or if it works,
We don't have it. No, we
let's
don't.
see if we can. I wanted to explicitly make that a problem. Okay, so try GCF first, then if it works or not, try a binomial. In this case, we have two terms. So let me look at this problem. So first of all, do we have a GCF?
Nope, we don't.
We don't. Right? We have 9 here, we have 25. Nothing is common, the x is not common. If we do, then we would factor that first. We will factor that first. We have a difference here. Could we maybe use this formula? Can we?
Yes, we can.
Squares? At least this one.
Yeah, that's 5 times squared, yeah.
And it has to be perfect squares, not just this. We call it the difference of two squares, two perfect squares. You can say two perfect squares. Does that mean it has to be x to the second, not some decimal or some fraction or something, or x to the power 3 over 2. It has to be perfect square, just the whole number 2. So let's make two squares out of this. Let's make this basically look something like this. at least we have the minus. That's good. We have a square here. 25 is 5 to the second. Let's try to write this as something squared. Once we write this as something squared, let's say we have our formula. So we have the squares we need and the minus. The squares are here and the minus. At least for 9, how do you write 9 as something squared? So 9.
3x in a cube, in a third, I don't know how we call it in English.
That's right.
3x in a cube.
Exactly. So at least 9. So we can get 9 by doing 3 to the second. And x is 6. We want to square it. So again, we say this. We want power to be 2 outside. So x, we have a power here.
It's
power, that's right. Some power here. That's when you times these, you get 6. What number goes here in order to?
3.
3.
So it's a cube.
Always put the 2 outside. So this is going to be 3. X to the third. Again, all we did was square this. So 9 is 3 to the second. X is 6. To square it, again, we use this rule. So we times the 2, you get 3 times 2. Or you can think of it this way. 3x to the second, it means 3x times 3x. 3x to the third, actually. So 3 times 3, that's 9. What's x3 times x3? What do you do with the powers?
You just wait, you just add them.
We add them. You add them, we get 6. Again, if you got a little confused about the last part, I strongly recommend you go back to reviewing the rules of exponents. All these rules we discussed in detail in a whole class or two, actually 2 classes. So rules of powers or exponents. I believe that was probably the second or maybe the third class. Probably the third class. So review that. These last 2 will make a lot more sense. I understand if these are a little tricky now, but it's just simple rules of exponents. I already explained them here, so make sure you review those so this can make more sense. And what else? So now, do we have this in this form? This one here, does it look in this form? Difference of 2 squares. So this is again what we call difference of 2 squares. This formula here. Do we have difference of 2 squares here? Yes, we have a difference.
Yeah.
We have 2 squares. All we have to do is turn this into parentheses. And again, you do that by taking what's end of the powers, and you write that twice. Once with a minus, once with a plus. Okay, so what goes inside here? If we take just under powers.
So 3x time in the 3.
That's right. So 3x minus 5.
Minus 5. Wait, I got a question. Don't you use a cube word when you use the number 3 in a square?
As a power?
3.
Yeah, you can say.
Plus,
you mean if we could use the word cube?
yeah.
That's right. This is x cubed. Okay, or x to the third power. And this is also x squared or x to the second power. Yeah, you can say x cubed.
Yeah.
When the power is 3, we call it a cube. And when the power is 2, we call it a square. So squared. And that's basically our final answer here. Can't factor this. There's no big common, no squares, no GCF. Same thing here. Okay, so this kind of combines a few things. Combines the rules of exponents in addition to this formula, in addition to factoring. Okay.
So that's the final answer, Professor?
That's it. Yeah, that's the final answer.
Oh, okay.
Don't worry too much about these last 2 if you don't understand them yet. Again, I recommend you review the exponent rules before you try these again later. But for now, just make sure you understand up to here. This is nothing too bad here. Binomial, you use this right away. trinomial, attempt GCF first. If not, use check for A and D, and then use the parentheses. And that's any other questions, everybody, about any of this? Again, factoring is very important. Make sure you understand this well. We're going to be using this for the next few classes. So I'm going to post this, rewatch it, review it. And if you have any questions from it, please let me know during our next meeting. Okay. So, any questions, everybody?
No.
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 All right. So you'll see plenty of examples of practice problems in the homework, which we'll post soon. Again, everything we covered will be in the midterm, so make sure you review this, do the homework, that way you prepare for the midterm. And also, now we can do that part in the review sheet, so we can do that part of factoring here. So again, the midterm is next week on Wednesday. All of the homeworks are due by the midterm day. Less chance to submit them. They're part of your grade.